Hey y'all. Sorry I'm a little late. I forgot my periodic table. But we'll wait for a couple of you guys to go ahead and pop on in before we get started. How is everyone today? How's your Tuesday? Good, that's good. As you're getting ready for class, go ahead and, hey, make sure you have a periodic table today. Well, I'm going to be honest. You're going to need a periodic table every day. Sorry, I forgot my periodic table. I'm glad. It was a struggle today. Good. I'm glad you guys are all here. Is anyone enjoying the cold weather today? Glad you guys are all here and saying hi. How do we connect our YouTube to Canvas? So DK asks, how do you connect your YouTube to Canvas? You can click the links. Otherwise, my suggestion will be to follow my channel, and it will email you every time I go live. It will go live. Today, I forgot my notes, so I had to run back to my office. Otherwise, it should start a few minutes before 4:30. It is ugly out. I feel like these kind of rainy days make me want to stay home and like watch TV or really do anything. Fly in your oven. I want to bake. Maybe cookies, breads. Not pancakes, but like dreary days do not make me want to do anything. All I want to do is stay home and do nothing. Hi, Christopher. We just started. So, before we talk about the problem solving session today, does anyone have any questions about course material? What you should have done this week before this started. So on my channel, you will also find videos from the lecture portion that you should watch on Mondays. So those videos are things like, there was a naming one that was pretty, I don't want to say exciting. But that's a pretty good one on how to name compounds. So you should have watched several videos before today. It will make today easier. If you haven't watched them, because I can tell based on the views, some of you guys aren't watching them. I will send out more links later this week. So DK, it's totally fine as long as you're okay that I call you DK. So Marlo asks, will the mini exams be on chapters 1, 2, and 3, or just chapters 1 and 2? So the mini exam will cover everything that we've talked about in the problem solving session. So I think it'll be chapters 1, 2, and the beginning of chapter 3. Yes, that will definitely be correct. There is a Snapchat group. There's also a GroupMe account, which someone has sent me a link to. So if you are interested in that, there's a Snapchat group. There's also the GroupMe. You can send me an email, and I'm happy to send you that along. So Haynes, which I think is how you say that, asked, was it just 1.7? Was it just chapter 1? It was also chapter 2 for today. So if you haven't watched it, much of this you will already know. We're going to talk about protons, neutrons, electrons, naming, but we're going to do some math questions that are a little bit more tricky. So If you've already started this week's ALEKS, good job. If you haven't, I'm going to give you some tips and tricks along the way to maybe try to make it a little less agonizing when it keeps telling you, like, you've done the sig figs wrong. But stay tuned for that. Bri asks, when is our first exam? It is in February. Our first mini exam is, I think, in 2 weeks. But I have not yet memorized that, and I didn't write it down. So you can find that information on the front page of our Canvas page, or if someone else knows when the exam is, can you drop that in the chat? What do we have to have down with ALEKS? Caleb asks, what do we have to have down with the ALEKS? All you need to do is do whatever it asks you to do every week. That's it. So every week, so this week I think there were due on next Monday the 18th, maybe 10 to 11 objectives, but you might have tested out of some. If you didn't test out of some or you didn't finish last week's, it will give them to you as you need them. Sky asks, mini exams have replaced that, so you do not need to do that. There are no weekly assignments if you were here last semester. They're just the mini exams. There's 3 of those. Dammy asks, which playlists? The chapter 1 and chapter 2 both have videos. And when I post the links for chapter 3, every playlist should start with the lecture videos, then some example videos. Don't read the modules, everything's in there. It's not false. So Alyssa says, you just watched the videos for 1.5 and 1.6. So this week is week 2. So you're a week behind, but that's okay. You're going to catch up. Today I'm going to help you learn everything you need to know. The videos in the future, you want to make sure you watch the videos for the week before you come to the live. When you come to the live, we're going to work more example problems. Most of these will have written myself, so they'll be like you'll see on the exam. Or I've tried to adapt them from ALEKS, and I'll tell you when we get there so that for the trickier problems, you guys know what to do. So that's good. Amber asked, are the exams mini exams like the ALEKS questions? Overall, no. I will have written them. They're a little bit closer to the worksheet problems if you've looked at those on Canvas. I try to write all my own questions, so they're not like ALEKS. Sometimes ALEKS is frankly a little crazy. Ooh, Marlo says the first mini exam is January 25th. Christopher asks, does it cover the first 3 chapters? No, it will not cover all of the material on the exam. It'll cover chapters 1, 2, and part of 3. So not this week's weekly announcement, but next week's. We'll tell you everything you'll need to know about it, what you need to do, how's it gonna work, all that. So if you're not reading my weekly announcements, you definitely should. I will include a picture of Lily this week. So stay tuned, check her out on Friday. ALEKS can be confusing, but in a couple of weeks, you'll understand all of its weird quirkies. Christopher asked, where will we take the mini exam? It will be on Canvas in the Canvas quizzes. Wesley says that ALEKS made me want to punch a hole through my laptop. I'm not going to lie. That made me laugh. I'm really sorry. I promise, well, I don't promise. ALEKS can be that way. But I will always try to teach you the tips, tricks, and the best path forward to maybe make it a little less irritating. In ALEKS, one of the things that I think will help you guys be less like Wesley wanting to punch a hole in your laptop is if you write down how to do the problem by hand instead of just like trying to like do it all mental math or in your calculator. ALEKS is going to make you figure out if you know it. And it's going to do that, and I don't like to say it tricks you, but it's going to ask you the same question, like forwards and then backwards and then upside down and round around, and that can be really annoying. I promise that ALEKS is way better than the alternatives. The mini exam, I haven't written it yet, so I don't know what it will be like, but it will not be multiple choice. If that's what you're asking, I hate multiple choice, so there will be no multiple choice really ever, but it will be calculations and everything else. I'm sorry that you missed mastering. I think ALEKS is better for you than mastering. I've used mastering. I didn't like it. Mastering always felt a little rigid. I want you to have the flexibility to get credit for what you already know and learn things as you go. It will get better as you go. So Sky says, if you don't understand a question on ALEKS, then I write down the explanation and use that to do the next one. Good idea. Sarah asks, are the quizzes and exams with HonorLock? Only the exams will be using Respondus. The other ones will be a little bit less locked down. So Amber asked, can you explain the assignments, worksheets, and when are they due? Sure. So right now, the only thing that you have to do, the only thing, is to do your ALEKS homework every week. The worksheets that are on there are more practice problems because I think in the grand scheme of things, one issue that students often have is that the homework is homework and they want another way to study. So the worksheets that you can find in there, and I'm gonna post a video where I walk through Canvas and tell you all the cool things later this week. That video will show you all the things, but the worksheets are never due, they're just practice. If you finish the worksheet and you'd like it to check it against the key, you can email it to me, come to my office hours, or something else. And then if you are not, if you're like, office hours, just email me, I will check over your worksheet for you. Otherwise, I will post the keys closer to exam 1 so that you guys can actually try. Y'all are making me laugh today. Okay, any other questions, thoughts, comments, concerns? Anything else? Otherwise, we will start on our questions for the day. So, let's tell you a little bit about how this is going to work today. If you found the worksheet on Canvas, it looks like this, but without my writing on it. It says problem solving session January 13th, 2021. There are 4 pages, 9 questions. If you didn't print this out, that's okay. I am going to just, we can actually drop questions right up here. Hopefully you can see that. If you find that the font is too small to read, just send me an email and I'll work on it. It looks big enough for me, but that's how it rolls. So in that case, Sky asks, can you take the mini exams, actual exams at the library? Yes, that's right. Go Aggies. Yeah, you can take them at the library as long as you're in a room all by yourself. And so that's kind of up to you. But if you think that the wireless internet at UNF is better than your location, you should do that. Because it's okay if things fall apart, but we'll figure that out. Christopher asked, do you need a functional printer? No. But all of this is designed so you can print it. But if you would prefer, you could also just download it to a tablet. Or you can use a regular notebook and just refer back and forth. Zara Lost says, I felt validated by completing my pie, but was quickly let down by more pie. I feel you. But this first week is the most objectives you would have ever seen. All of the rest of them are between 8 and 10, and so it will not take as long as it did this past time. So, or maybe it will, maybe it won't, but it will not be as many different things. Okay, if you have questions, I'll answer them after I finish number 1. So question number 1 states, a certain chemical releases 13.2 kilojoules per gram of heat for each gram of reactant consumes. It says how can you, but let's just scratch that out and say calculate the heat produced by the consumption of 3.1 kilograms of reactant. So in number 1, the first thing we're going to do is basically set stuff up. So we're going to take our 32.2 kilojoules per 1.0 grams. So anytime you have a kilojoules per gram, you can basically just drop that out. I'll screw Uncle Lights in this after class. So from here, we're now going to multiply that by the number or the mass of our quantity, which in this case is 3.1 kilograms. So from here, we can now set this up, but we can't cross out these units because grams and kilograms are not the same. So what we can do is we can now convert kilograms. So 1 kilogram is 1,000 grams. And so when you plug this into your calculator, which I totally forgot to bring with me, it's clearly the first day of school, we have 99820 kilojoules. But our least favorite friend, significant figures friends, are going to control how we set this up. So in this case, the number of significant figures for the answer is going to be 2. And it's going to be 2 because this number only has 2 significant figures. This one has 3, but in the problem we multiplied and divided. So the multiplication and division is controlled by the value with the least total number of sig figs. So in this case, it's going to be 2. So we're going to have just 2. And then we have to round. I like to use regular rounding, 5 and up, round up, 4 and down, round down. So this is going to round up because 998 is going to round up to 100. So when we do that, it would be to round this value, but that only has 1 sig fig. So we're going to have to use scientific notation. So scientific notation is 1.0 times 10 to the 4th kilojoules. Alex, our homework system, loves scientific notation. I don't actually care that much. So in a different world, if this gave you if this was a different value and it didn't round, I would accept 99,000. You could write it out, you could put it in scientific notation. I will accept both. Alex will make you choose the other one because that's what it likes. I am way more flexible. So this is one Alex tip that is a little weird, but totally true. Marissa asks, are you going to post the worksheet with your answers on it on Canvas? I'm not planning on it. I will only do that if we don't finish it. But while this doesn't sound the same, all of this is the same stuff that's on here. So I will only post it if we don't finish it, and I'll post the ones that we didn't get to. Good question, though. Jenna, thank you. This took a lot of effort, and I'm very proud of the questions on the board. I'm pretty proud of that. Okay. Any other questions about number 1? If you don't have any questions or you thought it was easy, drop that right over here in the chat, and we'll move on to number 2. Not seeing any questions. So we'll start on number 2, but I will leave up the work for number 1 just in case. So question number 2 asks, 1 gram of gasoline produces 45 kilojoules of energy during combustion. Gasoline has a density of 0.772 grams per mil. How much energy is released when 6.82 liters are burned? This question has 2 parts, basically. We have density, and we have some unit conversions. It does round to 100,000. Thank you. So the correct answer will be 1.0 times 10 to the 5th kilojoules. Nice catch. Yes, I can scoot out of the way for a second. Sorry about the math error. Okay, I'm gonna go ahead and start number 2, but I'm gonna try to stand to the side so y'all can see how that other works. So on number 2, the first thing I'm gonna do is use the density to convert the liters of gasoline into grams. And we wanna do that so that we can figure out how much energy is released, because it's energy per gram, and we're gonna start in liters. So in this case, we're gonna take our 6.82 liters, and in 1 liter, there are 1,000 milliliters. Then we're gonna multiply that by the density of 0.772 grams in 1 milliliter. Once you do that, you get 5,265.04 grams. So now that we have the grams, let me make my decimal point more visible. We want to be able to determine the amount of energy based on the kilojoules per gram. So we're going to take our 45.0 kilojoules per 1 gram multiplied by 5,265.04 grams, which is going to give us 236,926.8 kilojoules. With our significant figures, in our problem, the least value is 3. They're actually all containing 3. So we want to round it back to 3. So we're going to end up with 2.37, because the 9 rounds this to 7, and times 10 to the 5th kilojoules. At least that's what I got when I plugged it into my calculator earlier. Does anyone have any? Sorry. It's kind of hard to figure out where to stand to where you're not in the way. But do we have any questions about this? If you don't, you can go ahead, write in this chat box over here, drop the word none, or it was easy, or got it. Anything to let me know that you are following along. Or you can let me know if I did the math wrong. Nice, thanks, Amanda. Look at all this, it's great. Nice. So Caleb asks, So Kayla and Emma have some really good questions. So Caleb asks, why did you use the 0.772 for the conversion? So we started with liters, but our value here is 1 gram of gasoline produces 45 kilojoules of energy. So we need to be able to determine the amount of gasoline that we have in grams. In order to do that, we have to use the density to convert. So that's what we did right here out of the problem. So in this case, we took our liters of gasoline, converted that to 1,000 milliliters using unit conversion, and then we used the density to get grams. Once we had the grams, you could multiply that by the kilojoules per gram to where the grams will cancel, and that gives you the kilojoules. Some of you may be curious, so I broke this up into 2 parts. You can put it all together in almost any way you like, but you do not need to stop at this part. You could have basically put the 45 per gram here and kept going. So Emma asked, why did you use the 45 over 1 gram? And it's a good question. So in this case, 1 gram produces 45 kilojoules. In this case, because we want to know the energy, we needed a way to determine how much energy per gram. And so we did that using this. So anytime you can think about it, if there are 6 slices per pie, it will be 6 over 1 if it was slices per pie. And we did the same thing here. Dammy asks, so we don't always have to put it in scientific notation? You don't. You could have also left this answer as 270,000 as long as the number of significant figures was correct. Alex, just to be clear, will ask you to put it in scientific notation and may mark it wrong, but it'll give you kind of a warning in that case. Jeffrey asks, these are auto-uploaded? Yes. So you can find this. I need to make a semester playlist, and I will link that in Canvas so you can find it super easy, but it'll be in there. So Murray asks, can you explain why you plug those numbers in? Sure. This is the volume, and we wanted to use the density, which is mass per unit volume, to get grams. In this case, the 45 kilojoules per gram multiplied by the grams gives you the energy. So right now we're just working with density and unit conversions. In chapter 5, we will talk about what this energy actually means. Glad to help. Let's look at number 3. Here's a marker. So number 3 asks, Christopher, that's correct. Number 3, a chemist working as a safety inspector finds an unmarked bottle in a cabinet. A note on the door of the cabinet says the cabinet stores bottles of 5 different chemicals. Next, the chemist measures the volume of the liquid at 1,674 cubic centimeters. And the mass of the liquid is 1.18 kilograms. What is the density? So density is mass per volume. And in Gen Chem, it's almost always mass in grams and volumes in milliliters. In other sciences, it could be grams per liter or something else. In this case, we're going to look for grams per mil. So the first thing we're going to do is take the mass of 1.18 and convert that to grams. So in 1 kilogram, there are 1,000 grams. So we're going to get 1,180 grams is our mass. So the kilograms and milligrams and micrograms, that table that you find early in chapter 1, you're going to need to know the ones in the video or in the slide deck that tell you need to memorize these, right? So kilogram, you need to know every time. So for the volume, it turns out that cubic centimeters are the same as milliliters. So we're going to take our 1,674 cubic centimeters and convert that in 1 cubic centimeter is 1 milliliter, and that gives you the same number, 1,674 milliliters. So from here, when you divide the mass per volume, you're going to get a density of 0.716 grams per milliliter. And we'll double check in the problem. 1.18 has the least number of sig figs, and so that is the number of sig figs that we need. So in this case, this was a relatively easy density calculation. In the other one, we used density. In this case, by calculating both the mass and the volume, we were able to determine the density of our unknown. If you finished all of your objectives from last week, you'll notice that this might look similar. It also had a table where you had to say, can we identify the density or the unknown? So I do try to pick from ALEKS particular things where in the past students have had questions. So if you have any questions on number 3, go ahead and drop that right over here in this chat box. If you have a question, drop it. If you have none or you thought it was easy, you can go ahead and drop that in the chat box too. Nice. Thanks, Amanda. Density is easier than we feel like it should be, right? Let me use my calculator. So Sean, Anasha, and Robbie, I think that was all of you, are definitely correct. I have no idea what had happened. So this is, in fact, as they mentioned, 7.05. I wish I could tell you what had happened, but I must have pushed the wrong digit on a calculator. But it's a nice time to tell you, in this course, I will always look at your work. Your work is important to me. So let's say you had gotten some other weird number. You could get substantial partial credit, in this case, for setting it all up correctly, and then just having a calculator meltdown at the bottom. So Bry asks, do you care if we use negative exponents for units? I don't mind at all. As long as your units are there, if you put them as negative exponents, I can understand that. If you use them as grams per mil like this, I will also get that. So I'm pretty flexible as long as you use units and they are in fact correct. So negative or positive exponents is okay by me. Good question. So those 3 questions were kind of a review from chapter 1 type stuff. So for the next, however long we have, for as much as we have, what we're going to start to do is work our way through chapter 2. And so there are some multiple examples, and some of them, if you've looked ahead, have like tables to fill out. So we may not do all of the examples, but we're going to do a bunch of them. So in this case, it's asking for the empirical formula. The empirical formula is the base unit. If you divide all of the subscripts by a value, what do we get? So in this case, for A, which is C2H4O2, all of those subscripts are divisible by 2. So the base unit, or the empirical formula, is going to be CH2O. So the empirical formula is going to be important as we move forward to start to think about the molecular unit, the complex unit, or an ionic compound. So in this case, you just divide all of the subscripts by any value, as long as it's the same value for all of them. So B, in this case, is calcium bromide. So CaBr2. In this case, the calcium has a subscript that we don't use, but it's 1. So the empirical formula for CaBr2 is just CaBr2. So there is no change in this case. For number C, question C, we have C6H6. So both of these are divisible by the number 6. So the base unit in this case is CH. So do we have what questions do you have about empirical formula? And if you have none and you were like, got it, you could let me know that in the chat too. So Tammy asks, why are we dividing the subscript again? So the subscript is it tells you who is who in the pool. So these compounds or complexes are molecular. The empirical compound or the empirical formula is the base unit. So you just divide by the least common denominator in that case. So we are dividing in order to find the empirical formula. Sure. So in this case, all of these can be divided by 2. So the empirical formula is what is the base unit for all of these compounds. And in this case, it is carbon, 2 hydrogens, and an oxygen. To get back to this, we would multiply this compound by 2. We will begin to do calculations with them later next week for sure. So this week, for the most part, we're just asking what is the empirical formula. Next week, we will start to use the empirical formula. Good questions. So yeah, I'm glad to help out, Matthew. So our next question, question number 5, says, scientists collect the following data about ruthenium. Ruthenium-99, so one isotope, is 97.30% abundant and has a mass of 98.91 atomic mass units. Ruthenium-104, so another isotope, is 2.70% abundant and has a mass of 103.91. Using this information, calculate the atomic mass. So atomic mass is equal to the sum of the isotope mass multiplied by the fractional abundance over all isotopes. So in this case, we want to know what percent of the mass comes from ruthenium-99 and what percent of the mass comes from ruthenium-104. So in this case, we're going to take our ruthenium-99, and the isotope mass can be found in the problem. In this case, it's 98.91 multiplied by the fractional abundance. So to get the fractional abundance, we take the percent abundance and divide by 100, or just convert to fraction. So in this case, it would be 0.9730. And we're going to add that to the fractional weight from ruthenium-104, starting with the isotope mass, which is 103.91 atomic mass units, multiplied by the fractional abundance, which in this case is 0.0270. So now we're going to start to plug this into our calculator. I'm going to do this ordinarily. We would just plug this all in our calculator, and you will get mostly the right answer, but the wrong significant figures. So in this case, when we multiply this together, we get 96.24. Both of these values have 4 significant figures. When we multiply these together, our answer will only have 3 significant figures. So it will be 2.81. When we add these together, when we do addition, the significant figures is based on the number of points after the decimal point. And so 96.24 plus 2.81 gives us 99.05 atomic mass units. Now, Alex is going to attempt to be extra Alexy. If you set it up like this, you will get the right number of sig figs every time. Where it gets kind of murky is if you were to have only thought about the multiplication, you might have thought the final answer was 99.1. Alex will just say, you have the wrong answer. It's not going to tell you, based on your significant figures during addition, you got the wrong answer. So this is how, if you calculate the mass, and we have another problem coming up here in a little while that'll show you a different type of calculation that Alex will also ask you to do. So Amanda, let me scoot out of the way. So Amanda asks, will this formula be provided on a test? So an equation sheet is up there, but this one will not be provided. However, your exams are open notes, so I would suggest making some version of a study guide that will help you. So Alexa asked, I couldn't get the last objective on the Alex assignment because of that. Do you still get credit for the other ones? It is okay to be new? Yes. So if you look on the homework's grade, it's posted in Canvas, you got points for whatever percent you accomplished. So if you did 50% of the objectives, you got 5 points. If you just didn't do one, you probably got 9 point something points. So Caleb used let me check my calculation to make sure everything is above board. So Christopher, I got 96.05 by doing this math, by multiplying these two together and then trimming the significant figures at each step in this case. When we do multiplication questions, you can do it all at once. Because it's multiplication and dividing, it turns out you have to do your significant figures twice. You have to do them for the multiplication here, and then for the addition, which gives you this. So Caleb, you would lose part of your credit. So Alex might mark it all the way wrong. I would give you significant partial credit, but you do not have the correct final answer. So Dean asks a good question. Why would the significant figures be 4 if you use 3 and 2.81? Because addition sig figs are not about the total. It's about the number of places after the decimal. So in this case, these both have two places after the decimal, and so that's where this number comes from in that case. So multiplication is the least total number of sig figs. In addition and subtraction, it's the numbers after the decimal place. Good question. So Remy asks, can you explain how to get the abundance again? Yeah. So abundance, or fractional abundance, all right, yeah. So fractional is just the percent abundance divided by 100. So you just want to convert your percentage back into a decimal point. So if you know that it is 0.5 abundant, you know that that is 50%. So it's basically converting a percent back to a decimal or in the opposite direction. So hope you should get the same answer. As long as, so in this case, you should set it up as one calculation, then the other, then add them together to get this answer. It all has to do with the sig figs. Otherwise, it'll always work. Just plug it all in your calculator at the same time. Christopher, it's okay. I lose decimal points all the time, so that's kind of, I thought that was it. Glad to help. We will do another example of this in just a second. We're going to do some protons, neutrons, and electrons, and then we will move on as we go forward. Any other questions about this example before we talk about number 6? I feel like you guys have asked all the questions. So Matthew, this answer should have 4 sig figs because the 3 was used in the addition, the multiplication, and when you add them together, it's about the number after the decimal point. Okay, so in the next question, we are going to fill in the following table. So this is the same table as you would find kind of bigger on the graphic, but so we're going to look at 6 different compounds or 6 different isotopes and ask how many protons, neutrons, electrons, and what is the mass number. So if we look at the first one, which is manganese, so we're going to, whoops, make sure y'all can actually see me. Protons, neutrons, electrons, mass. So we're going to start with manganese 54. So in this case, the small number at the top is the mass number. Sometimes you see them with a number at the top and the bottom next to the element symbol, but not always. So this here is the mass number. So we're going to put that right here. The mass number is not the atomic mass out of the periodic table. It is the total of the protons plus neutrons. So to determine the protons and electrons, we need a copy of our periodic table. So we can find manganese in element 25. So the number of protons and electrons are consistent because it is not an ion. So the number of neutrons in this case would be 29 because the neutrons are the mass minus protons. And the protons equals electrons as long as it's a neutral species. So let's look at O17 or oxygen 17. So we know that the mass number is 17. Based on the periodic table, we have 8 in both of these as well as 9. So for iron 57, based on its periodic table location, we know it's at 26. So in this case, again, because it's neutral, we know that they're going to match. The mass number can come directly from here. So in this case, the neutrons would be 57 minus 26, which is 31. So now let's think about what happens if it's an ion. So an ion has removed an electron. Whether it's positive or negative, we just remove electrons. The protons never change. The number of neutrons changes based on the isotope. So if we have platinum 2 plus 195, we know that the mass number is 195. Based on the periodic table, we can determine that it is element 78. 195 minus 78 is 117. So it's platinum 2 plus, which means that we've removed 2 electrons. So in this case, it will not be 78, it will be 76. I see some questions. Jenna, that is not a dumb question. I'm always happy to answer them, but I appreciate someone else hopping in there while I was busy. So feel free, if you know the answer to your classmate's question, you can go ahead and drop it in the box at any time. But you should assume it's neutral unless it says this ion. So these little charges here at the top tell you that it's charged. Great question. So what about if we have arsenic 75, 3 minus? So now we have a negative component. So in the positive, we lost electrons. So in this case, we know that it's 75 is the mass number. It's element 33. And 75 minus 33 is 42. And so because it is negative, we've added electrons. We've added, in fact, 3 electrons because that's what the charge is. So in this case, we have 33 plus 3 to give us this negative charge. It means we have more electrons than we have protons. So that will be 36. So does anyone have any questions? I know there's one more, but I want to make sure we get through most of these as we get through. So does anyone have any questions about calculating protons, neutrons, electrons, mass number? In order to determine the mass number, you either have to be provided the protons and the neutrons, or the neutrons and the electrons. This number should always be a whole number, not a number in the periodic table. Well, that didn't really work the way I'd hoped. So if you have questions about the protons, neutrons, and electrons, go ahead and drop it in the box. If you don't, that's good. Let's think about how we can combine these anions and cations to make compounds. So in this case, one of the things that we need to think about is molecules, whether it's an ionic compound or molecule, are inherently neutral. There are some negative or positive molecules, but most of the time they're neutral. But in this case, what we're going to do is we're going to start to mix these together. So in order to figure out what the compound is, we have to know what the charge is. Oh, Haynes just asked, you would, and in just 1 second, I'll drop the answer in the chat box for you guys. Just kidding, I'll do that now. What do you guys think about this question? So for protons, there's 38. Neutrons. If you're looking for the answer to the last line from the previous box, you can find it in the chat box right now. So you can check it there. So in order to do these, and I'm going to do as many as I can, but we're going to stop in about 6 or so minutes. I want to make sure we get through as much as we can. Where I picked too many problems this week. So in this case, what we want to think about is what do they look like? So for calcium and bromide, we need to know what the charges are. So in this case, we can determine the charges based on our periodic table. So if you watched in the video, I talked about how elements in specific columns have specific charges. Elements in the transition metals, the no rules kids, we have to have clues, such as the Roman numerals or a charge, in order to tell us what their charge is. By and large, if they're in the periodic table in the middle right here where the transition metals are, they have more than one oxidation state. So we have to be able to decide, is it +2 or +3? And we can't do that just by looking at it. We're going to have to use our context clues. So in this table, over wherever it is, you can see that in the second line, it says Cu Roman numeral 1. That tells you it's going to be a copper 1 ion. So it's going to be a copper +1. So let's look at some of these. So if we have calcium 2 plus and Br minus. When those mix together, we're going to get calcium Br2 because that's how it becomes neutral. In this case, the goal is to have a neutral molecule. When we look at these, we want them to be neutral. So whatever it is, the two need to come together. What I'm trying to say is that if this is 2 plus and this is 1 minus, in order to make it neutral, you need one of these for every two of these. So for the next one, we have copper plus and oxygen 2 minus, which means we need 2 copper atoms for every 1 oxygen, which would be Cu2O. So it's going to be the same for basically everything in this table. We just need to think about how do we get them to be balanced. So what about for K plus N3 minus? So we're going to need 3 potassiums for every 1 nitrogen. If we think about aluminum 3 plus and sulfur 2 minus, in order to look at this, now it's getting more complicated. Up until this point, it's just been add more of one than the other. So some students like to use kind of this like flip-flop method, where the charge on this one is the subscript here, and the charge on this is the subscript here. I've never seen that not work. It doesn't mean it won't always work, but it definitely should work. It's also true, you'll notice up here, for these charges as well. So in this case, we will have aluminum 2, sulfur 3. So all we're doing is figuring out what it is from the ions. Later today, hopefully, we're going to start to make naming for these. We're going to ask ourselves, what would you call K3N? So it would be potassium nitride. So as you think about these, you can start to mix and match, and then you can go ahead and actually just start to try to name them as you go along. So when we have magnesium 2 plus and the acetate ion, which is C2H3O2 minus, now we need to have more than one acetate ion. So the acetate ion is a polyatomic ion. So the polyatomic ion just means it has a bunch of atoms and they live together. They're like a compound. Well, they're not like a compound. They are a compound. And that compound stays together to make any charge in that case. So in this case, we have magnesium, but we need 2 of these. And so we designate that by C2H3O2. Now you'll notice I used parentheses here because it is that we have 2 of these whole molecules, not C4H6O4. We can't multiply the subscripts because that's a different atom. But I'm seeing some questions. So Christopher asks, if I only give you the protons and electrons, you cannot determine the mass number. You have to have another data point, either the number of neutrons or something else. Hope says they are terrible at naming. It's taken me a long time to be really good at it. It's practice. My suggestion would be to use note cards to memorize your polyatomics. I also, in your Canvas, so in the weekly announcement last week, I gave you hyperlinks to a periodic table that looks like this. I like it because it has the names and the masses. On the back, not the back, this is when I used to make paper copies. You can also find a copy of the polyatomic ion table. You need to memorize all of these. These are all your friends. There is a different polyatomic table on ALEKS. You are not responsible to name those on my assignments. ALEKS gives you that, and that's what it's going to ask for. I only need you to know these. So Bri asks, I think about this one, but I do agree that it could be that my handwriting, this is calcium 2+, and this is copper+. So in the copper plus, in order to balance the O2-, you need to have 2 coppers. We're doing good. Okay. We're running out of time today. So I am going to take this down. We're going to do the next math problem, but I will post the solutions for 7, 8, and 9 later today. Nitrite is a different polyatomic. Good question. So before you guys jet off, also I will hang out for a few extra minutes after 5:45 and ask as many questions. Jenna is correct. This 2 goes with calcium Br2. So copper would just be Cu2O. This, note to self, this is, I have poor board work today. I was trying to put too much stuff in the same space. So the bromine had a subscript of 2 that did appear to be hanging out with the oxygen. That was totally false and too much text, not enough space. So sorry about that. So the last math question we're going to look at today is the atomic weight of lithium is 6.938 atomic mass units. If one isotope, lithium-7, accounts for 92.41% of the natural weight and weighs 7 point blah, blah, blah atomic mass units, what is, typo in here, what is the mass and abundance of the other isotope? Don't be sorry, we're happy to answer your questions. In this case, this one is quite tricky. ALEKS, this is on ALEKS, this comes from ALEKS. Make sure that you try to follow the significant figures in this case. So, I'll just move right over here. So the abundance is 100 minus 92.41. So this is the fact that if lithium only has 2 isotopes, it is 100% abundance. So we can determine the abundance of the other by subtracting the first isotope from the second. So 100 minus 92.41 gives us 7.59%. So now we know the abundance, which is half the problem. So we needed to know that information. From here, we're going to start to ask, what is the mass of the other isotope? So to figure that out, we know that it is 6.938 is equal to lithium-7 plus the other lithium. And so from here, I think it's lithium-8. But now we're going to be able to figure that out. So we can figure that out by using the same calculation where we take the fractional abundance of 92.9241 multiplied by 7.0160 AMU plus the other isotope. So once once you plug this into your calculator, you're going to get that the other isotope equals 6.938 minus 9.483, which that gives you 0.455. So this is the weight times the fractional abundance of the other isotope. So that equals the weight multiplied by the fractional abundance, which is 0.0759. So once we do this, we can determine that the weight of this value equals 5. Hold on. I don't think that number is right. I think I have a math error. Hold that thought. I guess that is right. We get 5.9947, and with sig figs, this is going to give you, so we would only have 3 sig figs based on this value, which comes from this value. So in this case, we would get 5.99 atomic mass units, as well as this value. So Anissa says she gets 5.987. Did you plug all of it into your calculator at the same time? Well, more than likely, that's what you did. For Alex, it's really important that you step through it one step at a time. For the mini exam and the exam, it is going to be less important that you do that. But Alex will ask you this, and you'll get here, and it'll be like, wrong sig figs, and it'll be a whole ordeal. So I think your answer is close enough that on my exam, you would likely get full credit. Because I would just call that like a slight rounding error. Somewhere in there, you didn't trim off all of your extra digits at the end, which in my mind is not a problem. Alex will have a problem. I will double check my math, but I think it's pretty close. Any other questions about this example? And I'll try to be still so I'm not standing in front of it. If you have to go, I'm going to hang out here for a few more minutes, but I will post the work for this, the end of this table from number 7, as well as the answers for number 9. But the rest of them, you can rewind the video and get the answers there. Questions about this example? If you don't have any questions, Haynes, you are free to go. You can always watch the end of the video later. It will be there. Sorry if we're running a little late today. Oh, Gabe, sorry, I missed your question. It would be lithium-6, yes. So Caleb asks, why did we keep going? So this value is this other isotope, and it asks you what is the weight of that isotope, and you have to calculate that using the fractional abundance of that isotope. Does that help? Yes, this one in Alex is often quite complicated. What you'll find is if you come to the live session, I'll give you some tricks on how to maybe streamline your Alex. Y'all have a great weekend if you're rolling out. I will see you around. Ooh, Dammy, I'm more than happy to talk about it again. So, fractional, or the isotope abundance, is the mass that comes from each different isotope, and you sum them up. So, the abundance is 100 minus the percent abundance for the other isotope, and you can get this. So, in this case, we know the mass is the fractional mass for isotope 1 plus the mass of isotope 2. From here, we're going to take our mass, and then we're going to subtract this value, which is 0.9241, multiplied by the mass of, in this case, lithium-7. When we do that, we're going to solve for x. And x is the other isotope. So you could have set this up where it was x times this fractional abundance. I've just broken it out in a slightly different step. So once you do this subtraction, you get 0.455. That is the mass that comes from the other isotope. But we need to know how much that isotope weighs. In this case, we're going to get that by determining the weight multiplied by the fractional abundance. So when we divide 0.455 divided by the fractional abundance, we get the weight of our second isotope. Ooh, that's right. If you're still around, there is SI tomorrow discussing this topic and naming. So Bri asked, ooh, you asked this early. I'm sorry. I remember reading it, but I wasn't paying attention. If you have digitally drawn notes on OneNote, my preference would be that you would download those to your computer or download them and disconnect it from the internet. Your notes are your notes, so if you've done them digitally, you can go ahead and do that. I will trust you that. I will say in that case, you need them to be separate because the browser lockdown won't let you access OneNote during the exam. So if you could download your notes to a PDF, you can use that, or you can download them if they're on your iPad as well. It's a good question about the significant figures. So ordinarily, if you're doing all multiplication, you can just do them at the end. When you do multiplication and division and some other things, you should do them every time you change type. So if you're adding, do your sig figs. If you're then going to multiply, do your sig figs, and vice versa. It's a great question. And this is the hardest sig figs of the whole semester. It will get easier after this. All great questions. If you guys have headed out, that's great. If you're still around, does anyone have any other questions? If not, y'all have a fantastic rest of your Wednesday. I will see you here on the live session next Wednesday, and we'll start chapter 3. Y'all have a great rest of the day.